So in my previous videos I showed you how to train an image classifier and an object detector using Yolov8. Now it's the time for semantic segmentation. I'm going to show you the entire process of how to train a semantic segmentation algorithm using Yolov8, from how to annotate the data, how to train the model in your local environment and also from a Google Colab, and finally a super comprehensive guide on how to validate the model you trained. My name is Felipe, welcome to my channel, and now let's get started. So let's start with today's tutorial, and the first thing I'm going to do is to show you the data we are going to be using today. So this is a dataset I have prepared for today's tutorial, and you can see that these are images of ducks. We are going to be using a duck dataset today, and this is exactly how the images look like. Now for each one of our images, for absolutely every single one of our images, we are going to have a binary mask. We are going to have an image, a binary image, where absolutely every single pixel is either white or black, and absolutely every single white pixel is the location of our objects. All the white pixels are the location of the objects we are interested in. In this case, the objects are our ducks. So let me show you an example so it's a little more clear what I mean regarding the white pixels are the location of our objects. So this is a random image in my dataset, this is a random image of a duck, and this exactly its binary mask. So take a look what happens when I align these two images and when I apply something like a transparency. You can see that the binary mask is giving us the exact location of the duck in this image. So this is exactly what it means that the white pixels are the location of our objects. So this is exactly the data I am going to be using in this tutorial, and now let me show you from where I have downloaded this dataset. This dataset I have found in the Open Images dataset version 7. Let me show you this dataset super quickly. This is an amazing dataset you can use for many different computer vision related tasks. For example, if I go to segmentation, you can see that we have many different categories. Now we are looking at a random category of fonts. This is, for example, a semantic segmentation dataset of fonts, and let me show you, if I go here and I scroll down, you can see that one of the categories is here, duck. So this is, for example, the exact same data I am going to be using in this tutorial. This is the exact same duck dataset I am going to be using in order to train a semantic segmentation algorithm using Yolov8. And obviously you could download the exact same data I am going to use in this tutorial. If you go to Open Images dataset version 7, you can just download the exact same duck dataset I am going to be using today, or you can also download another dataset of other categories. So this is about the data I am going to use in this project, and this is about where you can download the exact same data if you want to. Now let me show you a website you can use in order to annotate your data, because in my case I have downloaded a dataset which is already annotated, so I don't have to annotate absolutely any of my images. Absolutely all of my images already have its binary masks, right? I already have the masks for absolutely all the images in my dataset. But if you're building your dataset from scratch, chances are you will need to annotate your images. So let me give you this tool which is going to be super useful in case you need to annotate your data. It's called CBAT, and you can find it in cbat.ai, and this is a very popular computer vision annotation tool. I have used it I don't know how many times in my projects, and it's very popular and it's very useful. So I'm going to show you how to use this tool in order to annotate your images. So the first thing we need to do is to go to start using CBAT. This is going to ask you to either register if you don't have a user already, or to log in, right? I already have a user, so this is logged into my account. And now let me show you how I'm going to do in order to annotate a few images. Actually, I'm going to annotate only one image, because I am only going to show you how to use it in order to create a binary mask for your project. But I'm just going to do it with only one image, because it's, you only need to see the process, and that's going to be all. So I'm going to projects. I'm going to here to the plus button, create a new project. The name of this project will be duck semantic semseg. This will be the name of my project, and it will contain only one label, which is duck. So I'm going to press continue. And that's pretty much all. Submit and open. Now I'm going to create a task. This is already, yeah, create new task. The task name will be doc task 01. It doesn't really matter the name, so I just selected a random name. Then I'm going to add an image. I'm just going to select this image. I'm just going to annotate one image, so this is going to be enough, and submit and open. So this is going to take a couple of seconds. This is where you need to select all of your images, all the images you want to annotate, but in my case I'm only going to select one. So I'm going to press here in job. So this is going to open the annotation job, right? Now I'm going to show you how you can annotate this image, how you can create a binary mask for this image. You need to go here to draw new polygon, then shape. So I'm going to start over here, and this is pretty much all we need to do in order to create the semantic segmentation dataset for this image, right? In order to create the binary mask for this image. You can see that I'm just trying to follow the contour of this object, and you may notice that the contour I am following is not perfect. Obviously this is not perfect, and it doesn't have to be perfect. If you're creating a dataset, if you are creating the mask of an image, if you are creating the mask of an object, then it definitely doesn't need to be pixel-wise perfect, right? You need to make a good mask, obviously, but something like this, as I am doing right now, will be more than enough. So this is a very time-consuming process, you can see, and this is why I have selected only one, because if I do many images, it's going to take me a lot of time, and it doesn't make any sense, because the idea is only for you to see how to annotate the images, right? So you can see that I'm following the contour. Okay, and this is an interesting part, because we have reached the duck's hand or its leg or something like that, this part of the duck's body, and you can see that this is beneath the water, this is below the water, and this is where you're going to ask yourself, do you need to annotate this part or not? Do you need to annotate this part as if it's part of the duck or not? Because you could say, yeah, it's definitely part of this duck, but you are not really seeing a lot of this object, right? It's like part of the water as well. So this is where you're going to ask yourself if you need to annotate this part or not. And in my case, I'm going to annotate it, but it's like you can do either way. In all of those sections, in all of those parts where you're not 100% convinced, then that's like a discussion. You could do it, you could not do it, it's up to you. So annotating a few images is always a good practice, because you are going to see many different situations, as I have just seen over here, right? Where I have just seen with this part of the duck, which now I am super curious what's the name. If you know what's the name of this part of the duck's body, please let me know in the comments below. I think it's called hand, right? Because it's something like a hand they have over there. But let me know if it has another name, and if you know it, please let me know in the comments below. Now let's continue. You can see I'm almost there. I have almost completed the mask of this duck. Now I only have to complete this peak or whatever it's called. It seems I don't really know much about duck's anatomy. I don't really know how the name of this part either. So anyway, I have already completed, and once I'm completed, I have to press Shift N, and that's going to be all. So this is the mask, this is the binary mask I have generated for this object, for this duck, and this is going to be pretty much all. What I have to do now is to click Save. You can see that this is definitely not a perfect mask. This is not a perfect, like pixel-wise perfect mask, because there are some parts of this duck which are not within the mask, but it doesn't matter. Make it as perfect as possible, but if it's not 100% perfect, it's not the end of the world, nothing happens. So I have already saved this image, and what I need to do now is to download this data so I can show you how to download the data you have just annotated in order to create your dataset. So This is what I'm going to do. I'm going to select this part, this option over here, and I'm going to export task dataset, and then I'm going to select this option, which is segmentation mask 1.1. I'm just going to select that option and I'm going to click OK. So that's going to be all. We only need to wait a couple of minutes and that's pretty much all. The data has been downloaded. Now I'm going to open this file, and basically the images you are interested in are going to be here, right? You can see in my case I only have one image, but this is where you're going to have many images. And please mind the color you will get all these images in, right? In my case, I have downloaded this image in red. It doesn't really matter, just mind that you could have something different than white. But once you have all your images, what you need to do is to create a directory. I'm going to show you how I do it. I am going maybe here, and I'm going to create a very temporal directory, which I'm going to call TMP, and this is where I'm going to locate this image, right? And I'm going to create two directories. One of them is going to be masks, and then the other one is going to be called labels, and you're going to see why in only a minute. And this is where I'm going to locate the mask here. And then I am going to PyCharm, because I have created a script, a Python script, which is going to take care of a very important process. We have created masks, which are images, which are binary images, and that's perfect because that's exactly the information we need in order to train a semantic segmentation algorithm. But the way Yolov8 works, we need to convert this image, this binary image, into a different type of file. We are going to keep exactly the same information, but we are going to convert this image into another type of file. So let me show you how. This is a Python file I have created in order to take care of this process, and the only thing you need to do is to edit these fields. This is where you're going to put all the masks. This is a directory which is going to contain all the masks you have generated, and this is going to be the output directory. You can see that these two variables are already named properly in my case, because this is a TMP directory I have just created. This is where I have located the mask I have just generated with CPAT, and this is my output directory. So take a look what happens when I press play. So the script has just been executed, everything is okay. This is the mask I had input, and this is the file which was generated from this mask. And this looks super absolutely crazy, right? It's a lot of numbers, it's like a very crazy thing. Without going into the details, let's just say that this is exactly the same information we had here. This is exactly the same information we have here, but in a different format. Let's keep that idea, right? Exactly the same information in a different format, and that's exactly the format Yolov8 needs in order to train the semantic segmentation model. So this is exactly what you need to do. Once you have created all of your masks, you need to download these files into your computer, and then please execute this script so you can convert your images into a different type of files. And obviously this script will be available in the GitHub repository of today's tutorial. So that's pretty much all in order to create your annotations, and in order to download these annotations, and in order to format everything the way you should. Now let me show you the structure you need to format, the way you need to structure all of your file system so it complies with Yolov8. Remember, this is something we have already done in our previous tutorials regarding Yolov8. Once you have your data, you need to structure your data, you need to format your data, you need to structure your file system so Yolov8 finds absolutely where everything is located, right? You're going to locate your images in a given directory, you're going to locate your annotations, your labels in another directory, so everything is just the way Yolov8 expects it to be, right? So let me show you. I have a directory which is my root directory, which is called data. Within data, I have 3 directories, but this directory, the masks directory, is not really needed. It's just there because that's the way I got my masks, my data, but it's not really needed. And in order to show you this directory, which is the one containing all of my binary masks, in order to be more clear that this is not needed for this part of this process, what I'm going to do is I'm going to delete this directory, right? Now it's gone. Okay, now we only have 2 directories, and these are exactly the directories we need in this part of this process where we are creating all the structure for our data. So images, you can see that we have 2 directories. One of them is called images, the other one is called labels. Within images, we have 2 other directories. One of them is called train, and the other one is called val. And train is the directory where we are going to have all of our training data. This is where we are going to have all of our training images. These are all the images Yolov8 is going to use in order to train the model, in order to train the semantic segmentation model. Then val also contains images, and these are the images we are going to use in order to validate the model, right? So remember, you need to have 2 directories. One of them should be called train. It's very important, the name. It should be called train, and the other one should be called val. Now, going back, you can see that we have 2 directories. One of them is images, the other one is label. And if I go within labels, you can see that there are 2 other directories. Also, they are named train and val. And if I open these directories, these are the type of files I have generated with the exact same script I showed you a few minutes ago. So, within labels, we have 2 directories, train and val. And train are all the annotations we have generated from the training data, from the training masks, right? Long story short, we have our root directory. Within the root directory, we have 2 directories. One of them is called images, the other one is called labels. Within images, we have 2 directories, train and val. Within train and within val, it's all of our data, all of our images. And within labels, it's exactly the same structure. 2 directories, train and val, and within train and within val, it's where we locate all of our annotations, right? That's exactly the structure you need for your data. Please remember to structure your file system like this, otherwise you may have an issue when you are trying to train a semantic segmentation model using Yolov8. So that's pretty much all in order how to structure the data. And now let's move to the interesting part. Let's move to the most fun part, which is training the semantic segmentation model. Now, let's move to PyCharm, and I will show you how to train it from your local environment. So let's continue. This is a PyCharm project I created for today's tutorial. Please remember to install these project requirements, otherwise you will not be able to use Yolov8. Now let's go to train.py. This is a Python script I created, and this is where we are going to do all the coding we need in order to train the semantic segmentation model using Yolov8. And now let's go back to the Yolov8 official repository, because let's see how exactly we can use this this model in order to train the semantic segmentation model. I'm going to the segmentation section, and I'm going to click on segmentation docs. Now, this is going to be very straightforward. I'm going to train, I'm going to copy this sentence, which is load a pre-trained model, and I'm going back to PyCharm. I'm just going to copy paste, and then I am going to, from Ultralytics, import YOLO. Then I'm also going to copy this sentence, which is the model.train. I'm going to change the number of epochs to something like 1, because remember, it's always very healthy, it's always a very good idea to do like a very dummy training, to train the model for only 1 epoch, to make sure everything is okay, to make sure everything runs smoothly, and then you do like a more deeper training. So I'm going to change the number of epochs, and then I'm also going to change the config file. I'm going to use this config file, which is a config file I have over here. And obviously you will find this config file in the repository of today's video. So long story short, you can see that you have many different keywords, but the only one that you need to edit is this one, right? This is the absolute path to your data. In my case, if I copy and paste this path over here, you can see that this is the directory which contains the images and the labels directories. So long story short, just remember to edit this path to the location of your data. Because if you have already structured everything in the way I mentioned, in the way I show you in this video, then everything else will be just fine, right? The train and the val Keywords are very good as it is. I mean, you can just leave everything as it is, but please remember to edit this field, which is the location of your data. Now going back to train.py, this is pretty much all we need to do in order to train the semantic segmentation model. So I'm just going to press play and let's see what happens. And you can see everything is going well. We are training our model, but everything is taking forever. Everything is just going to take forever. Even though we are only training this model for only one epoch, everything is going to take a lot of time. So what I'm going to do instead is just press stop. I'm going to stop this training. Everything is going well. I'm not stopping this training because I had an error or something. No, everything is going well. But I am going to repeat exactly the same process from a Jupyter notebook in my Google Colab. Because if I use Google Colab, I'm going to have access to a free GPU and it's going to make the process much faster. So I am going to use a Google Colab in order to train this model, and I recommend you to use a Google Colab as well. So I'm going to show you how to do it from your Google Colab environment. Please remember to upload your data before doing anything in Google Colab. Please remember to upload your data, otherwise it's not going to work. For example, here you can see I have many directories. One of these directories is data, and within data you have labels and images, and these are exactly the same directories I have over here. So I have already uploaded my data into my Google Drive. Please remember to do it too, otherwise you will not be able to do everything we're going to do just now, right? So that's one of the things you need to upload, and then also remember to upload this config.yaml file, the same file I show you in my local computer. You also need this file here. The only thing you will need to edit is this path, because now you need to specify the path, the location of your data in Google Drive. So I'm going to show you exactly how to locate your data into your Google Drive, and now let's move to the Jupyter notebook. Obviously, I'm going to give you this notebook. This is going to be in the GitHub repository of today's tutorial, so you can just use this notebook. I'm just going to show you how to execute absolutely every single cell and how everything works, right? And exactly how everything, exactly what everything means, right? Exactly what are you doing in absolutely every single cell. So the first thing I'm doing is just connecting my Google Colab environment with Google Drive, because remember, we need to access data from Google Drive, so we definitely need to allow Google Colab to access Google Drive. So I'm just going to select my account, and then I scroll all the way down and press allow. That's going to be pretty much all. We need to wait a couple of seconds. And now let's continue. What I'm going to do now is to define this variable, which is data_dir, and this is the location of my data in my Google Drive. Now please mind this path, this location, because please mind the way this is structured, right? Please mind the first word is content, then G drive, then my drive, and then is my relative path to my data. So if you want to know exactly where you have uploaded your data, if you're not completely sure where you have uploaded your data, what you can do is to do an ls like I'm doing right now, and this is going to give you all the files you have in the root directory of your Google Drive. Then from there, just navigate until the directory where you have uploaded your data. In my case is my drive, computer vision engineer, image segmentation, Yolov8, and then data. That's exactly where my data is located in Google Drive. If I go to this directory, you can see that this is my drive, then you can see that this is my drive, then computer vision engineer, image segmentation, Yolov8, and then data. And this is exactly what I have over here. So once you have located your data, the only thing you need to do is to edit this cell and to press enter. So everything is ready. Now I'm going to install Ultralytics so I can use Yolov8 from the notebook. And this is going to take a few seconds, but this is going to be ready in no time. Or something you need to do from your Google Colab is to go to runtime and change runtime type. Just make sure it says GPU. Just make sure you are using a Google Colab with GPU, because if you are not using a Google Colab with GPU, everything is pretty much pointless, right? So just remember to to check if you are using a Google Colab with GPU or not. Just do it before you start all this process, because otherwise you will need to run absolutely everything again. So let's continue. I have already installed Ultralytics, and now I am going to run this cell. And if you realize, this is exactly the same type of information, the same code I have over here in my local environment, right? I'm just defining a model, and then I am just training this model. So what I need to do now is just press enter, and also mind that I have specified the config file, right? The location of my config file. And now I'm going to run a full training, or actually I'm going to run a training for 10 epochs. So this is what I'm going to do. And this is also going to take some time, although we are going to use a GPU. This is going to take a few minutes as well. So what I'm going to do now is just, I'm going to wait until this is completed, and I'm going to pause my recording here, and I'm just going to fast forward this video until this process is completed. Okay, so the training process is now completed. We have trained this model and everything is just fine. And you can see that the results have been saved here under runs, segment and train 2. So the only thing we need to do now is to get the results we got from this training. We need to get the weights, we need to get all the results, all the different metrics, all the different plots, because what we need to do now is to analyze this training process. We need to validate that everything is just fine, right? So what we are going to do now is to get all this information, and the easiest way to do it is just running this command. What we will do when running this command, we are going to copy all the content in this directory where the results have been saved under our Google Drive, right? Remember to edit this URL, remember to edit this path, this location, because you want to copy everything into a directory into your Google Drive. So just make sure everything is okay, make sure this location makes sense, and you can just execute this cell and you're going to copy everything into your Google Drive. Now let me show you my Google Drive. I have already executed this cell, so everything is under my Google Drive. This is a runs directory which was created when I ran that cell, and under this other directory which is called segment, we have train 2. So these are all of our results. These are the results we are now going to analyze. So what I'm going to do now is just to download this directory, and once we have this directory into our local computer, then we are going to take a look at all the plots, at all the metrics, and I'm going to tell you exactly what I usually do in order to validate this training process. So everything is now downloaded, everything is now completed, and let's take a look at these files. So what I'm going to do is I'm just going to copy everything into my desktop. I need to do some cleaning, by the way. So these are all the results we got from this training process. You can see that this is a lot of information. This is definitely a lot of information, right? We have many different files. We have many different everything. We have the weights over here. We have a lot of information. So let me tell you, let me give you my recommendation about how to do this evaluation, how to do this validation. From all these plots and from all of these results, I will recommend you to focus on two things. One of them is this plot, one of them is all of these metrics, and then I'm also going to show you how to take a look at these results, at these predictions from these images. But for now, let's start here. You can see that this is a lot of information, these are a lot of metrics, and you can definitely knock yourself out analyzing all the information you have here. You can definitely go crazy analyzing all of this information, all of these plots, but I'm going to show you like a very simple and a very straightforward way to do this analysis, to do this validation. This is something that I have already mentioned in my previous videos on Yolov8, on how to train a model and how to validate this model, which is take a look what happens with the loss function. Take a look what happens with your loss plots, with all the plots which are related to the loss function. And as this is a semantic segmentation type of algorithm, I will tell you, take a look what happens with this loss, with the segmentation loss. I will say, take a look what happens with the training loss and the validation loss. And long story short, just make sure the loss function goes down, right? If your loss function is going down, it's likely things are going well. it's not a guarantee. Maybe things are not really going that well and the model doesn't really perform that well. It may happen. But I will say that if the loss function is going down, it's a very good sign. If, at the contrary, your loss function is going up, I will say you have a very, very serious problem. I will say there is something which is seriously wrong with your training process, or with your data, or with your annotations, or with something. You have done something seriously wrong, or there's something seriously wrong with your data. But I'm talking about something amazingly wrong, seriously wrong, right? If your loss function is going up, I don't know what's going on, but something is going on. Do you see what I mean? So having a loss function which is going down, yeah, it's not a guarantee of success. I mean, it's not like it's a good model for sure. No, you may have a situation where you haven't trained a good model and your loss function is going down anyway. But I would say that it's a very, very good sign. At the very least, your training loss and your validation loss should go down, and I'm talking about a trend of going down, right? For example, here we have a few epochs in which the loss function is going up. That's okay, that's not a problem. We are looking for a trend. We should have a trend for the loss function to go down. And that's exactly what we have in this situation. So, long story short, that's my recommendation on how to do this validation, how to do this analysis on all the metrics we have over here. For now, focus on these two and make sure they are going down. And then, in order to continue with this process, with this validation, is that we are going to take a look at what happens with our predictions. How is this model performing with some data, with some predictions? And for this, we are going to take a look what happens with all of these images, right? You can see that these are some badges, and these are some of our labels, some of our annotations for all of these images, and then these are some of the predictions for these images, right? So we are going to take a look what happens here, and for example, I'm going to show you these results, the first image, and you can see that looking at this image, which again, these are not our predictions, but this is our data, this is our annotations, these are our labels. You can see that there are many missing annotations. For example, in this image, we only have one mask, we only have the mask for one of our dogs. We have 1, 2, 3, 4, 5 dogs, but only one of them is annotated. We have a similar behavior here, only one of the dogs is annotated. Here is something similar, only one of them is annotated. And the same happens for absolutely every single one of these images. So there are a lot of missing annotations in this data we are currently looking at. And if I look at the predictions, now these are the same images, but these are our predictions, we can see that nevertheless we had a lot of missing annotations. The predictions don't really look that bad, right? For example, in this case, we are detecting 1, 2, 3 of the 5 dogs, so we have an even better prediction that we had over here. I would say it's not a perfect detection, but I would say it's very good, right? It's like, it's not 100% accurate, but it's like very good. And I would say it's definitely better than the data we used to train this model. So that's what happens with the first image, and if I take a look at the other images, I can see a similar behavior, right? This is the data we use for training this algorithm, and this is the predictions we got for these images, and so on, right? It seems it's like this, exactly the same behavior, exactly the same situation for this image as well. So my conclusions by looking at these images, by looking at these predictions, is that the model is not perfect, but I will say performs very well, especially considering that the data we are using to train this model seems to be not perfect, seems to have a lot of missing detections, have a lot of missing elements, right? A lot of missing objects. So that's our conclusion, that's my conclusion by looking at these results, and that's another reason for which I don't recommend you to go crazy analyzing these plots. Because when you are analyzing these plots, remember, the only thing you're doing is that you are comparing your data, the data you are using in order to train this model, with your predictions, right? The only thing you're doing is you're comparing your data with your predictions, with the predictions you got with the model, right? So as the only thing you're doing is a comparison between these two things, then if you have many missing datations or many missing objects, or if you have many different errors in your data, in the data you're using to train the algorithm, then this comparison, it's a little meaningless, right? It doesn't really make a lot of sense, because if you're just comparing one thing against the other, but the thing you are comparing with, it has a lot of errors, it has a lot of missing objects and so on, maybe the comparison doesn't make a lot of sense whatsoever, right? That's why I also recommend you to not go crazy when you are analyzing these plots, because they are going to give you a lot of information, but you are going to have even more information when you are analyzing all of these results. And this is a very, very, very good example of what happens in real life when you are training a model in a real project. Because remember that building an entire dataset, a dataset which is 100% clean and absolutely 100% perfect, is very, very, very expensive. So this is a very good example of what happens in real life. Usually the data you're using to train the model, to train the algorithm, has a few errors. And sometimes there are many, many, many errors. So this is a very good example of how this validation process looks like with a data which is very similar to the data we have in real life, which in most cases is not perfect. My conclusion from this evaluation, for this validation, would be improving the data, taking a look what's going on with the data. And the next step would be to improve the data. And by looking at these results, one of the ways in which I could improve this data is by using the predictions I'm getting instead of the annotations I used to train this model. You see what I mean? If the predictions we are getting are even better than the annotations, maybe a next step would be to use these predictions in order to train a new model. Do you see what I mean? So by analyzing all of these results, you are going to make decisions on how to move forward, on how to continue. And this is a very good example of how this process looks like in a real project. This is pretty much how it works, or how it looks like when you are working in a project, when you are working either in a company, or if you are a freelancer and you're delivering a project for a client. This is pretty much what happens, right? There are errors, things happen, and you need to make a decision given all the information you get with all this analysis. So that's going to be all in order to show you this very simple and very straightforward way in order to validate this training process, and in order to make some conclusions regarding what's going on, right? And regarding to make some decisions in order how to move forward with this project or with this training process. And now let me show you something else, which is within this directory, the weights folder. This is where your weights will be located, right? Because if you are training a model, it's because you want to have a model in order to make predictions, in order to make inferences. And this is where your models will be located. This is where your models will be saved. And this is something I have already mentioned in one of my previous videos regarding Yolov8. Remember, you will have two models. One of them is called last.pt and the other one is best.pt. And the way it works is that, remember that when you are training a model, at the end of absolutely every single epoch, you are updating your weights, you are updating your model. So at the end of absolutely every single epoch, you already have a model which is available, which you can use it if you want to. So last.pt means that you are getting the last model, the model you got at the end of your training process. So in this case, I am training a network for 10 epochs, if I remember correctly. So this is the model we got at the end of the 10th epoch. And then best.pt means that you are getting the best model, the best model you train during the entire training process. If I show you the metrics again, let's see the metrics over here. You can see that we have many metrics which are related to the loss function, and then other metrics related to the accuracy on how this model is performing. And the way Yolov8 decides what's the best model in this case, which is a semantic segmentation type of problem, may be related to the loss function. Maybe it's taking the model in which you got the minimum loss, or it may be related to some of these plots, some of these performances which are related to the accuracy, to the performance. Maybe it's getting the model for which you got the maximum precision, for example, or the maximum recall, or something like that. I'm not 100% sure, I should look at the documentation, but the way it usually goes is that last.pt is the last model you train, so it's at the end of your training process, and then best.pt is your best model, and this best model is decided under some criteria. So that's basically how it works, and what I usually do is taking last.pt, because I consider that last.pt is considering way more information, much more information, because we are taking much more data, we are taking much more everything, right? In all the training process, we are doing many different things. So if you take the last model, you are summarizing way more information. That's the way I see it. So usually I take the last model, usually I take last.pt. And that's pretty much all in order to show you this validation, how this validating this model looks like. And now let's move to the prediction. Let's see how we can use this model in order to make inferences, in order to make predictions. So let's see how we can do that. So let's go to PyCharm, let's go to the PyCharm project of today's tutorial, and this is a Python script I created in order to do these predictions. This Python file is called predict.py, and this is what we are going to do. I'm going to start importing from Ultralytics, import YOLO, and then I am going to define the model path, the model we are going to use, which in our case, let's use last.pt from these results from this directory. So I'm going to specify something like this, last.pt. And then let's define an image path. Let's define the image we are going to use in order to get our inferences. So the image will be located, this will be from the validation set. I'm just going to choose a random image, something like this one. So I am going to copy, paste, and I'm just going to paste it here. So this is the image we're going to use in order to test this model, in order to make our predictions. And now I'm going to import CV2 as well, because I'm going to read this image, and then I am going to get this image shape. So this will be something like this. This will be image, and then this is image.shape. Okay. And now the only thing we need to do is to get our model by doing something like YOLO and then model path. Okay, and then we are going to get the results by calling model of our image, right? And this is it. This is all we need to do in order to get our results, in order to get our inferences. But now let's do something else. I am going to iterate for result in results. And now let's take a look at this mask. Let's take a look at this prediction. So I'm going to iterate like this for j mask in result.masks.data, and then I am going to say something like mask.numpy times 255, and this is our mask, and then I am going to resize it to the size of the image. So I'm going to input the mask, and then this will be, if I'm not mistaken, the order is this one, W and then H. So this is just the way it works. This is how we need to do it in order to get the prediction, and then in order to resize this prediction back to the size of the original image. So this is how it goes. And now the only thing we need to do is to call cv2imgwrite, and I'm going to save it. I'm going to save it here, and the name will be something like that. Let's call it output. This is only a test, so we don't really need to go crazy with the name. Let's call it output.png, and this will be our mask. And that's pretty much all. Let's see what happens. I'm going to press play. Let's see if everything is okay or if we have some error. Okay, so I did get an error, and yeah, this is because we need to enumerate I forgot the enumerate. We are not using J actually, so I could just iterate in mask, but let's do it like this. Okay, everything ran smoothly, everything is okay, we didn't get any error. And now if I go back to this folder, to this directory, I can see this is the output we got. And now, in order to make absolutely 100% sure everything is okay, and this is a good mask, this is a good prediction, I'm going to make an overlay. I'm very excited, I don't know if you can tell, but I'm very excited. I'm just going to take this image over here, and then I'm going back here, and I'm going to take the original image. I'm going to do an overlay, so this will be raised to top. I'm going to align these two images together, and now let's make a transparency and let's see what happens. And you can see that we may not get like a 100% perfect mask, but it's pretty well. It's like a very good mask, especially considering the errors we detected in our data. So this is amazing. This is a very good detection. This is a very good result. So this is going to be all for this tutorial, and this is exactly how you can train a semantic segmentation model using Yolov8, and this is the entire process from how to annotate the data, how to train the model, and how to validate this model, and then how to make some predictions. So this is going to be all for today. So thank you so much for watching this tutorial. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of projects I make in this channel. So if you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. I also invite you to take a look at what other videos I have published so far. For example, this is the video YouTube thinks is best for you. So if I were you, I will definitely check out that video. So this is going to be all for today, and see you on my next video.